Hello everyone, I'm back with yet another video of chapter electricity of grade 10 physics. So today we'll be dealing about the new topic called as electrical power and energy. So we already know what is energy, right? So energy is what is a capacity to do work. It is called as energy. We have already studied about it, energy in your lower classes also. So the power is a new term maybe. Okay, so power, how can we define power? Power is defined as the ratio of energy dissipated to the time. So this is what is called as power, or we can say that power is a rate of change of energy. Rate of change of energy is called as power, or energy dissipated by time is called as power. So when we are speaking about energy, here we are speaking about the heat energy. Okay, so instead of energy we can write as H, which is called as the heat energy, and time T. Okay, and heat energy can be also written as Vi into T. Heat energy can also be written as Vi into T divided by time. So T and T gets cancelled and we'll get power is equal to V into I. Okay, or there is another one formula for power, that is P is equal to I square R. Another one is P is equal to V square by R. And another one is P is equal to W by T. W means work by time. So these are the four important formulas of power. Okay, so we can make use of these important formulas to solve the numericals. According to the data given, we can make use of any of these four equations to find out the answer. Okay, and SI unit of power, it is energy by time. So energy is joules. We know energy, the SI unit of energy is joules per second. Okay, the SI unit is joules per second, and it is also called as watt. Joules per second is also called as watt. So this is the SI unit of energy power. Okay, so power is energy dissipated by time. So energy, the SI unit of energy, when we are speaking about energy, we will be speaking about the heat energy. Okay, so heat energy by time, and we have four different equations for power. According to the data given in the numericals, we can make use of any of these four equations. Okay, and when we are speaking about the SI unit, since it is energy by time, the SI unit of energy is joules and the SI unit of time is second. So it is joules per second, or we'll call it as watt. Okay, now let us move into some of the numericals, some simple numericals. Okay, the first one, a bulb of power 100 watt is connected to a supply of 220 volt. How much current will it draw from the supply? Read the question once again. Let me read the question once again. A bulb of power 100 watt is connected to supply of 220 volt. How much current will it draw from the supply? So this is the question. So let us write out what are the data given in the question. Okay, what are the data given in the question? So power is given as 100 watt. So we can write P is equal to 100 watt. Is connected to a supply of 220 volt. The value of voltage is given as 220 volt. How much current? You need to find what is the value for current. So we know for the equation power is equal to V into I. We have one equation we already studied, the first equation. Power is equal to V into I. So from this we can write I is equal to P divided by V. Okay, so the value of P is 100 and the value of V is 220. Okay, so if we cancels, we'll get the answer as 10 divided by 22, or we'll get the value for current I is equal to 0.45. Okay, 0.4545. So this is the answer of the current. Okay, so this is just a simple question. The values given in the questions are power and voltage. You need to find what is the value for current. So we know the equation power is equal to voltage into current. From this we can write I is equal to P divided by V. Substituting the values, we will get the value of current I is equal to 0.4545 ampere. Okay. Now let us have a look into the second question. The question is, the wattage of a bulb is 24 watt when it is connected to a 12 volt battery. Calculate its effective wattage if it operates on a 6 volt battery. Okay, so the cases, there are two different cases. Okay, let us write down the given data first. I'll read out the question once again. The wattage of a bulb is 24 watt. That means the power is 24 watt when it is connected to a 12 volt battery. So let us consider case 1. The power is given as 24 watt and voltage is given as 12 volt. Okay, calculate its effective wattage if it operates on a 6 volt battery. So the case 2 is You need to find out what is the power, but voltage is given as 6 volt. So this is a board 2011 question. Okay, so the voltage is given, but you need to find out the power when the same bulb is connected to a 6 volt battery. So the theme of this question is, we have a bulb whose power is 24 watt. So, and it is connected to a 12 volt battery. When it is connected to a 12 volt battery, we will get the power as 24 watt. So now we need to find out what happens when the same bulb is connected to a 6 volt battery. What will be the value for the power? This is the question. Okay. So we need to very clearly analyze this question, because the bulb is same. In both the cases, the bulb is same. There is no difference in the bulb. The value which is changing is only the battery, the value of the voltage. So since the bulb is same, okay, since the bulb is same, we can write that the resistance is same, right? The resistance is same in both the cases, right? Since the bulb is same, resistance will be also same. So we know the equation for power. So we have another one equation. We have studied equation of power is V square by R. Okay. So when we are calculating the power 1, let us write V1 square by R1, or it is R. And when we are writing the P2, it will be V2 square by R. Because since the resistance are same, we can write it as R. Okay. Now let us find out the ratio P1 by P2. That will be V1 square by R divided by V2 square by R. R and R gets cancelled, and we will get V1 square divided by V2 square. Okay, so we'll get P1 by P2 is equal to V1 square divided by V2 square. Okay, so from this we can write P1 by P2 is equal to V1 square by V2 square. So what you have to find? We have to find the P2 value. In case 2, what is the power? So let us write an equation for P2. So how can you write P2? P2 will be equal to V2 square divided by V1 square into P1. Okay, so the value of V2 square is 24. So the value of P1 is 24 into V2 square means what? 36 divided by V1 square is 144. So you will get the value for P2 is equal to 6 watt. So what is this 24? 24 is P1. What is V1? V1 is 12. 12 into 12 is 144. What is V2? It is 6. 6 into 6 is 36. So 24 into 36 by 144, we will get the final answer as 6 watt. So let me explain it once again. So we have two different cases. In the first case, when the voltage across the bulb is 12 volt, we are getting the power as 24 watt. Now we need to find out when the same bulb is connected to 6 volt, what is the power produced? This is the question. So since we are using the same bulb, the resistance will also be same. So this is the condition, or this is the point we need to consider here. So we can write P1 as V1 square by R, P2 is V2 square by R. So let us take the ratio of P1 and P2. That will be V1 square by R divided by V2 square by R. Since the resistance are same in both the cases, it both gets cancelled, and we'll get P1 by P2 is equal to V1 square by V2 square. So what you have to find is P2, right? So from this equation, we can rearrange as P2 is equal to V2 square by V1 square into P1. So substituting the values, the value of P1 is 24 watt. Then V2 square, V2 is V6, it is 36. V1 square, V1 is 12, its square is 144. So when we cancels, we'll get the value for P2 as 6 watt. Now let us have the last question. An electric iron has a rating of 750 watt to 20 volt. Calculate current flowing through it, its resistance when it used. This is also a board question. Okay, so let us calculate. So what are the data given? The power is given as 750 watt and the voltage is given as 220 volt. Okay, so you need to find out what is the current, and you need to find out what is the value for resistance. Okay, so we know that power is equal to voltage into current. Okay, so we know the equation for power, P is equal to V into I. So first we need to find out what is the value for current. From this, I is equal to P by V. So the value of P is 750 and the value of V is 220. So when we simplify, we'll get the answer for current as 3.4 amps. Okay, the value of current is 3.4. Direct substitution. Because the value of power and voltage is given. The first question is you need to find out the current. So P is equal to V into I. So I is equal to P divided by V. Direct substitution, we get the answer of current as 3.4 amps. What is the second question? You need to find out what is the resistance. By Ohm's law, what we know, V is equal to I into R, or R is equal to V divided by I. What is the value for V? V is 220 and the value for I is 3.4. So if you simplify, you will get the value for resistance as 64.53 ohm. Okay, the value of resistance as 64.53 ohm. So this was a direct question. This is also a board question. It was asked in 2011. Okay, so first is you need to find out the current. So P is equal to V into I, direct substitution. Similarly, you need to find out the resistance. By Ohm's law, we can write V is equal to I into R, or R is equal to V divided by I. We know both the values, just substitute and we'll get the answer as R is equal to 64.53 ohms. Okay, so that is all about the problems from energy. So we'll continue in the next class with another topic. Thank you all. Have a great day.